Okay, welcome back. We're talking about virtual memory and how each process is assigned a chunk of memory of its own, and it's all fake. That because you don't really have that much memory going on here. Let me hit a Control C to stop this guy, since I'm kind of done with him. Okay, there is a way. Not that I would ever recommend you do this. There is a file called Swappiness. I know it's kind of cute, Swappiness. That basically says what kind of swapping do you want me to do? 60 is sort of like the default setting. 100 is like 100% balance between how much pressure the memory has and how much disk you have. But don't. I mean, I'm serious. Unless you're a kernel programmer, don't mess around with this. It's just not worth it. There's a thing called swap on, swap off. That basically tells you the size of the swap file, although you can kind of tell that yourself. Swap on A, or S rather. Basically tells me where the swap file is and how big it is and that kind of stuff. If you're running out of virtual memory, not physical memory, you're running out of virtual memory, you might want to increase the size of the swap file. That you can do. You can look at the page in and page out of VMstat to see how many pages of memory are being swapped. IOstat. So I would love to be able to see how much stuff we're getting into and out of IO devices, but I'm missing some stuff. So I need this thing called sysstat. So I'm going to do that now. I'm going to do sudo apt-get install sysstat. Yikes. 2 S's. Sysstat. And what this will install some really cool tools for us. One of them is the lsof command, which lists all the open files. Now we're not. Here's all the things that are currently being opened. The other one is fuser, which basically gives me the list of the users, and there's SS and a bunch of other guys. So these are really cool commands for trying to figure out what's going on. Now, there's a thing in here talking about the scheduler. Is this a general purpose machine, or is it primarily like a web server where nobody goes to the console and does anything, right? So there's lots of different types of scheduling, because sometimes I want to prioritize what would be called foreground tasks. Humans, right? Humans logging onto the console typically get more processing power, more scheduling time than underlying things. So if I had a web server up and running and I logged in as an administrator on that machine, physically on that machine, then I'm going to get a higher scheduling on my stuff than the web server. Maybe that's not right. Maybe I want to alter the way this thing works. So I'm going to show you a goofy little file, and it's sys block sdaq scheduler. Okay, so here are the choices. Now, a scheduler for disk I/O depends on whether this is a physical disk or is it a solid state disk. Okay, so yours may not actually be like this. One of them is called completely fair queuing. That's what it's called. And basically it says first come, first serve. I don't care. I mean, I don't care who the heck you are. First come, first serve. That's fine. And that's typically the default. And it works well for like mechanical hard drives, and it works well for some server scenarios. And then there's one called deadline. Deadline means I want to minimize the latency. In other words, I want to schedule, but I don't want like web requests to be hanging out there forever. So deadline is one of the ones where you basically say latency is important to me. So yes, it's okay to schedule disk I/O, but there's some threshold here I don't want you to exceed. And then no op, which basically means, man, I don't have any scheduling at all. I don't really need any disk scheduling on a solid state drive. I really don't. Just first in, first out. Just do it. No rearranging. I mean, the only way you would ever use no-op is if you were on a solid state drive. If you swap this over to a physical hard drive and kept this scenario just the way it is, your machine would be slow as hell. I'm going to skip all the perf stuff. So on page 1088, they basically have a summary. And the summary goes like this. Hey, my server got slow. What do I do? And this is a good question that people ask on tech support sites. So I would run a ps-aux to look for a runaway process, a process that's just consuming CPU like crazy, because maybe something is stuck. I'd run vmstat to look for paging. Are you running out of physical RAM? Or I would run renice, or perhaps even kill, processes that were chewing up too much room, too much processing power. There is a way you can restrict the physical limit on the limit, how much memory that a process can use, called ulimit. That's kind of cool. So let me give you an example. So in a SQL Server world, when you set up SQL Server, I typically tell the machine, look, this is just going to be a SQL Server. It's not going to be doing anything else. So I'm going to give it 90% of the CPU. It's okay. You can be greedy. You can take 90, let's say I had I don't know, an 8-core system. Well, I'm going to give it 6 of the cores that only belong to the SQL Server. 6 of those cores only belong, and you can use them any way you please. And only leave 2 cores left over for doing everything else. That's a choice I made, right? Because I want this background task to run faster. So yes, you can restrict physical access. The next thing you would do is see if those cron jobs are actually running, or if they're stuck, or they're not running, or something. And those are basically the 5 checklist items. Okay, we have made it through these 2 chapters, and I'll see you guys again in some future chapter.